The UGI reaction involves the mixing of four components: an aldehyde, an amine, a carboxylic acid, and an isonitrile. It is a convenient reaction to generate diverse libraries and has been used in the past to synthesize anti-malarial compounds. The particular UGI reaction that will be demonstrated here involves the reaction of furfurylamine, benzaldehyde, Bach-glycine, and T-butyl isonitrile. This reaction produces an UGI product as a precipitate when run at 0.5 molar concentration in methanol.
Hello, I'm Jean-Claude Bradley. My lab is located in the chemistry department at Drexel University.
Hi, I'm Dr. Bradley's graduate student Khalid Mirza.
Today we present the optimization of a UGI reaction using Mettler-Toledo's Minimapper and Mini-Block technologies.
First, we'll show how to program the Minimapper to do liquid handling. Second, we'll do the isolation of the product with parallel filtration. And finally, we'll do the characterization using IR and NMR techniques. So let's begin.
The Mini-Block is a tool made by Mettler-Toledo that enables you to perform reactions in parallel. This Mini-Block consists of a 6x8 array of tubes with a filter at the base. These tubes can handle about 3.5 milliliters of solvent. A valve at the bottom of the Mini-Block will be kept closed during the addition of reagents, and then opened later when you are ready for the filtration step. You will vary three parameters for this reaction and look at the effect on the yield of the isolated product. First, the excess of one or two reagents will be varied across each row. Then, the solvent and concentration will be varied between rows. When planning experiments, it is useful to use a shared online spreadsheet like Google Docs, which can then be conveniently copied over to the Minimapper software. This setup allows for some crowdsourcing of the experimental design, where people from around the world could plan parts of the experiment without having to know how to run the liquid handler. The first step involves weighing the empty tubes to an accuracy of 0.1 milligrams. The Mini-Block is then sealed shut and mounted onto the liquid handler deck. There are 4 reagent bottles and 4 solvent bottles used in this experiment. The liquid handler uses a robotic arm equipped with a syringe and can deliver any source to any destination on the rack using the syringe pump. The current setup uses a 10 milliliter syringe that can accurately deliver a minimum of 100 microliters. To conserve reagents, add either 100 or 120 microliters of each reagent solution, prepared in methanol at 2 molar concentration. The reaction is carried out in 5 steps. First, the solvent is added to each tube. This is how you will vary the concentration and solvent composition. Then, the amine solution is added to all tubes, followed by the aldehyde, the acid, and the isonitrile last. This takes about 1 hour to complete. The Mini-Block is then removed from the liquid handler. You can clearly see that there are clear solutions in each tube. This is important because you want to make sure that all the reagents are soluble in all the solvents. It usually takes about 30 minutes for the first precipitate to form. The Mini-Block is mounted onto a shaker and left to mix overnight. After about 16 hours, the Mini-Block is removed from the shaker and you can see that most of the tubes have precipitate. The Mini-Block is now mounted onto a collection base, and the valve is opened for all the filter tubes at once. Vacuum is applied and the precipitate is caught on the filter of each tube. The valve is then closed and 1 milliliter of methanol is added to every tube using a micropipette. The Mini-Block is put on the shaker for 15 minutes. This washing step is repeated once more. After the last wash, the vacuum is left on for 30 minutes. Then the tubes are transferred to a desiccator under high vacuum for 1 hour. After the tubes are dry, they are weighed again and the amount of precipitate is determined by subtracting the empty weight. Unfortunately, there is enough variability in the tubes that each one must be weighed empty. A sample from each solvent system is analyzed by NMR to ensure that all products are pure. 700 microliters of deuterated chloroform are added to a reaction tube to dissolve the precipitate. The solution is then transferred to an NMR tube. A 500 MHz Varian Unity Innova NMR instrument is used to obtain a proton NMR spectrum. Once the instrument has been logged on, vNMR software is launched. The reference standard in the instrument is popped out, and the sample is placed in the spinner and inserted into the instrument. The sample is then locked, shimmed, and set to spin. Parameters for a proton NMR are loaded, and a spectrum is then obtained as a JCamp.dx file, which can be viewed online with the standard browser. The spectra can be hosted on a local server or uploaded to ChemSpider, so researchers looking for this molecule will be able to use the data immediately. To further analyze the sample, IR spectroscopy is performed using a Perkin-Elmer FTIR Spectrum 1000 instrument. The software is logged in, the top plate of the ATR is removed, wiped, and cleaned with an ethanol-soaked Chem wipe. A clean glass slide is placed on the ATR and screwed on, and the force gauge is adjusted to about 90 units. After collecting a background spectrum, the sample spectrum is obtained and processed for an ATR correction. The IR spectrum is also obtained as a JCamp.dx file for online viewing. The big difference between running a reaction in a round bottom flask to performing it in parallel is that it allows the organic chemist to ask new questions and challenge assumptions in a systematic way. Adding automated liquid handling into the equation frees up the chemist to spend more time thinking about the project at a high level and less on the details of every experimental run.
Hopefully this video will give you some ideas about your own reactions. Thanks for watching.